Let's start with a really fundamental question. A computer only gets numbers, right? Ones and zeros. So how on earth does it begin to understand human language with all its nuance and complexity?
It seems like a huge gap to cross. Machines speak math, and we speak in words, sentences, and ideas. How do you build a bridge between those two worlds? Well, it all starts with one surprisingly simple, elegant first step.
And that's exactly what we're going to unpack. By the end of this, you'll get the intuition behind that foundational step, the one that really makes all of modern natural language processing work.
That bridge has a name: tokenization. At its core, it's just the process of breaking down a chunk of text into smaller, more manageable units. We call these units tokens.
A really good analogy is to think about how we teach a child to read. We don't just hand them a thick novel and say, good luck. No, we start small. We teach them letters, then how to combine those into sounds and syllables, and then finally whole words. Tokenization does the same thing, but for machines. So let's think about the most obvious way to do this. You have a sentence. What's the easiest way to break it up? You just split it by the spaces. This is called whitespace tokenization. Simple and straightforward. And you know what? For a nice, clean sentence like this one, it actually works pretty well. This is a sentence becomes a neat little list of 4 words, or 4 tokens. It's vast, it's easy, but it's also a bit too simple for the real world. Because real language is messy. As soon as you introduce things like contractions or punctuation, the whole thing starts to fall apart. Look at this example. The period gets stuck to the word work, which isn't right. And doesn't is treated as one unique token, even though it's really 2 ideas, does and not. This creates a lot of problems for a model trying to learn patterns. So, those limitations are exactly why we need a better way. We have to move from just splitting by words to a much more flexible approach, using something called subwords.
Okay, so there are really 3 main strategies. We've talked about word tokenization and its problems. On the total opposite end, you could just split text into individual characters. The issue there is you get super long sequences and you kind of lose the meaning. The letters C, A, and T don't mean much on their own. The modern sweet spot is subword tokenization. It breaks words down into smaller but still meaningful pieces. Here's a perfect example. A model might not have seen the full word tokenization before, but it probably has seen token. A subword tokenizer is smart enough to break it into 2 pieces it recognizes, token and ization. That hashtag you see is just a special marker to say, hey, this piece is the end of a word.
And this is the real breakthrough. This approach means a model can understand words it has literally never seen before. It just pieces them together from the subwords it already knows. This almost completely solves the out-of-vocabulary problem, making our models way more robust. It's a true game changer.
So where does this actually get used? Let's talk about where tokenization shows up in the AI tools you probably use every single day.
Turns out, it's pretty much everywhere. When you type something into a search engine, that's tokenization. When you talk to Siri or Alexa, tokenization. Chatbots, machine translation, even the spam filter in your email, they all start with this exact same step. And for the really big models like BERT and GPT, this isn't just an option. It is the absolute non-negotiable first step. Before they can generate text or answer a question or do anything else, they have to tokenize the input. It's the cost of entry. This really sums it up perfectly. Tokenization is that essential bridge. It takes our messy, chaotic human language and transforms it into the clean, ordered patterns that a machine can actually learn from. So if you remember just one thing, let it be this. The way you choose to tokenize text fundamentally defines how your model sees the world. It's a small decision, but it has a massive impact on everything that follows.